Today we're going to be processing a little bit of gold from scrap computer parts. A lot of computer parts are plated with a small amount of gold, and with a little bit of chemical treatment, we can isolate it. The profitability of this endeavor depends entirely on how cheap we can get the chemicals and the computer scrap. The prices of the chemicals are pretty consistent, but the cost of the scrap can vary greatly. Ideally, you want to pay the least for the most gold content, but getting good deals takes a surprising amount of knowledge and research. The amount of gold in computer scrap varies greatly, and it depends on a lot of things like the manufacturer, the year of production, the particular part, etc. If you really want to cut a profit by processing the computer parts, you really have to know what you're paying for. I'm personally not even close to a master at gold recovery, so I made some bad purchases, and you'll see in the video that I didn't even get close to breaking even. In this video, the computer parts that I'm getting the gold from are known as printed circuit boards, or PCBs for short. We could also get gold from things like computer processors or connectors, but I decided I would stick with just the PCBs. The procedure for pretty much all of the computer pieces is exactly the same, so I felt it would have been redundant if I just kept repeating the process. In general, there's 3 major steps to recover gold from computer scrap. The first thing that we need to do is to separate the gold from the circuit boards by dissolving the metal that the gold is plated on. This step results in a mixture of gold flakes and a bunch of other debris, so the second step is to purify the gold. In this second step, we selectively dissolve the gold and leave behind pieces of circuit boards, plastic, etc. The 3 main ways to dissolve gold is to use cyanide, aqua regia, or a mixture of bleach and hydrochloric acid. At the time of making this video, I didn't have any cyanide, so I didn't include this, but I do plan to demonstrate it in the future. The third step is to precipitate the gold from a solution and to recover it as a gold powder. There are a few ways to do this, but I'm going to use the metabisulfite method because I think it's one of the cheapest and easiest ways. After the third step, we do have an optional fourth step, and that is to melt the gold powder into a solid piece. Okay, so these are the basic chemicals that are needed to recover the gold. For step 1, the part where we separate the gold from the boards, we need 3% hydrogen peroxide, concentrated hydrochloric acid, and the computer scrap. For step 2, the part where we dissolve the gold into solution, we'll use hydrochloric acid, but we have an option of either using nitric acid or bleach, depending on how we want to do things. In the last and final step, where we precipitate our gold from solution, we have our sodium metabisulfite. The computer scrap that we use here doesn't really matter, and it can vary greatly in shape or form. For this video, I decided to separately process PCBs from 2 different sources so that I can compare the yield that I got from each of them. At the end of the video, I will also process some gold that was sent to me by a fan named Robert Bradbury. Robert is the one who actually suggested I make this video, and he sent me some free gold, so a big thanks goes out to him. To start things off, I add the first batch of computer boards to a 1-liter beaker. Before adding it to the beaker, I weighed everything, and it was advertised to be about a pound, and it actually came out to be a little bit more than this at around 472 grams. It's pretty easy to see here that some of the boards are too long for the beaker, so we're going to have to cut some things. Most of the long pieces only had gold at each end, and there was no gold in between, so I simply just cut off the ends and discarded the middle part. Some of the longer pieces actually had gold over the whole length of them, and for these, I just cut them in half and saved everything. Just after a few minutes of cutting, I was left with mostly moderately sized pieces, and I was ready to move on. What we need to do now is separate the gold from the boards, and to do this, we use a mixture of hydrogen peroxide and muriatic acid. The typical ratio, and the one that I'll be using, is a ratio of 2:1 muriatic acid to hydrogen peroxide. It's really not important to measure things out exactly, and they just have to be mixed in rough proportions. I wanted to have a total volume of 800 milliliters, so I poured in about 250 milliliters of the peroxide and just topped things off to 800. The peroxide muriatic acid solution is then poured into the beaker containing our computer pieces. The moment that our solution is added, you can see that it starts to change colors, and there's visible bubbling occurring. We leave it here for several minutes, and over the course of something like an hour, it slowly takes on a darker and darker green color. What we're trying to do here is separate the gold from the boards by dissolving the metal that the gold is attached to. Most boards have a base layer of copper, which then has nickel plated on top of that, and then gold plated on top of the nickel. Muriatic acid alone is not strong enough of an oxidizer to react with either the nickel or the copper, and this is why we had to add the peroxide. In the presence of an oxidizer like hydrogen peroxide or oxygen gas, the reaction occurs and we can dissolve both the copper and the nickel. Even in the presence of the hydrogen peroxide, the reaction is still pretty slow, so the general procedure is to leave things for a week and to occasionally stir it. Even though it's only been something like 2 hours, when we stir things around, we can see that some gold has already been separated from the boards. To add more oxygen to the mixture and to keep things agitated and mixed, we can use an aquarium air bubbler. These things are pretty cheap and you can probably get it for something like $10 to $20, but before you use it, you're going to have to make a few adjustments. The bubbling here is a little bit too wild. The first thing that I did was I made a few cuts in the hose to try to make it so that all the air wasn't pouring out the front and some of it can move out the side. To keep the tube fixed to the beaker and to prevent it from flying everywhere, I just used a large piece of tape. I don't show it here, but when I went to run things, it was a little bit better, but the airflow rate was a little bit too high still. To limit things further, I used one of my clamp holders to pinch down on the tube and to restrict the airflow. When we turn things on now, we can see that the bubbling is much cleaner, and just to prevent splashing, I cover the top with some plastic wrap. It is very important though not to completely cover the top with the plastic wrap because we are pumping air into the beaker. After about a week, things should be done, so we get rid of the air bubbler and the plastic wrap that's on top. The contents of the beaker are then poured into a basic kitchen strainer. The beaker is washed a few times to get all the gold out of it, and then this is poured on top of the circuit boards. When we take a look at the beaker below the strainer, we can see that I've used way too many water washings. You can also see a lot of the gold flakes that we've separated from the PCBs, and for now, we put this solution to the side. What I do next is I place the strainer over another bowl, and I manually wash all of the PCBs using a squirt bottle. This step is done to wash away any loose gold flakes that might still be there, and to also find the PCBs that still have gold attached to them. All of the boards that have been completely cleaned can be disposed of, but the ones that still have gold can be included in future batches. Anyway, after several minutes of washing, we get pretty close to being done. In the end, almost all of the boards were completely stripped of their gold, and there were just a few left over that had a little bit of gold left on them. After the strain is removed, you can see that we're left with a small amount of gold at the bottom of the bowl. Going back to our beaker with our gold flakes in it, I mixed it around to get a uniform mixture, and now we're ready to filter it. I use a doubled up coffee filter in a plastic funnel, and I slowly filter everything through. Some of the larger gold flakes have a tendency to sink to the bottom of the beaker, so before I pour things, I mix everything up. We're going to be filtering through a few liters of liquid here, so it's going to take a little bit of time. As we filter more and more, a decent amount of gold starts to build up. At this point, I filtered the last of our greenish liquid, and I do a couple final water washings just to get all of the gold out. After all of the gold and the greenish liquid have been washed out of the beaker, I swap out the container that's below the filter. Once the container's swapped out, we can start filtering the stuff that we washed out of the strainer. The water that we're filtering here is much cleaner, and this is why we swapped out the container below the filter. All of the green water that we first filtered through is contaminated with metals, and it needs to be disposed of properly. This second portion is nearly pure water, so it can be simply poured down the drain, and if we combine both, we would just be increasing the amount of waste that we have to dispose of. Eventually, everything is transferred, and I use a wash bottle to try to get as much gold as I can to the bottom. I let it sit for a while for the water to slowly drip out, and this is what we're left with. I open up the filter paper here to show what we have, and it does look like we have a nice chunk of gold. The volume here is very deceiving though, and it looks like we have a lot more gold than we really do. The flakes of gold don't pack very well, so it looks like there's a bigger volume, and also there's a lot of bits of plastic and other things present. I move things around with a spatula, and I get the gold in the front, so you can see what's really happening in the next step. What we have to do now is dissolve the gold, and there's two main methods to do this. The first is by making something called aqua regia, and the other is by mixing hydrochloric acid and bleach. I'm going to first show the aqua regia method, and the first thing that we do is we try to cover everything with hydrochloric acid. Aqua regia is made by mixing hydrochloric acid with nitric acid in a ratio of about 3:1, so since it looked like we had about 50 mils of hydrochloric acid here, I added 15 mils of nitric acid. It's important to note that as long as you're near the 3:1 ratio, you should be fine. It really doesn't have to be super exact. At first, it doesn't really seem like too much is happening, but after we leave it for a little bit with occasional stirring, eventually all of the gold does dissolve. While we wait for things to dissolve, I'm going to get into a little bit of the details on how it actually is dissolving the gold. If we were to use either of these acids alone, it really wouldn't do very much. Hydrochloric acid alone pretty much does nothing, but nitric acid alone is able to transiently oxidize an almost undetectable amount of gold. The reaction between nitric acid and gold is in equilibrium, and almost immediately after the gold is oxidized, it turns back into metallic gold. When the acids are mixed, though, we can actually dissolve gold pretty easily. When combined, the nitric acid will still oxidize very small amounts of gold, but this time, the oxide doesn't revert back to metallic gold. Almost as soon as the gold ions form, they react with the chloride ions from hydrochloric acid. The reaction between the gold and the chloride leads to the formation of very stable chloroaurate anions. By sequestering the oxidized gold ions, we're breaking the original equilibrium that we had between the gold and the nitric acid, and the gold slowly dissolves. In an acidic solution, the chloroaurate anions are associated with a hydrogen, and this is known as chloroauric acid. The chloroauric acid is our final product in this reaction, and it's extremely soluble in water. Once all the gold has dissolved, we'll be left with a nice yellow solution. The gold solution is then filtered through a coffee filter. All of the gold solution slowly filters through, and our original beaker is washed with a little bit of water. The contents of the coffee filter is then repeatedly washed with distilled water to try to get out as much gold as possible. Gold in solution will have a slight yellow color, so we'll know we're done washing when the stuff that filters through is colorless. Eventually, it looked like we were just filtering through plain water, so the filter was removed. To our gold solution, I then add a heaping spoonful of sodium metabisulfite. The sodium metabisulfite quickly reacts with both the nitric acid and the hydrochloric acid to produce sulfur dioxide gas. This gas is very irritating and toxic, so it's extremely important that this is done in a well-ventilated area. Some of the sulfur dioxide will react with gold ions dissolved in solution, and it will produce metallic gold. The reaction doesn't appear to occur immediately, but upon standing for a little bit, it starts to darken as the metallic gold precipitates out. We eventually reach a point where the solution doesn't get darker, and it looks like all of the gold has precipitated out. When I let things sit there for a while, the gold should slowly sink to the bottom. Now when I swirl things around, all of the gold should accumulate in the center of the flask, and when we look, we have a small clump of black gold. One step I didn't show here was the stannous chloride test, but I'm going to show this later in the video. The basic purpose for this test is to make sure that all of the gold is precipitated and that there's no gold left over in solution. To separate the gold, we then have to do another filtration, but this time I use proper filter papers and not coffee filters. I found that the precipitated gold was super fine, and coffee filters really didn't do a very good job catching it. Even though the filter papers were a lot better, they still weren't perfect, and a small amount of gold still passed through. Anyway, for now we'll let this filter through, and we'll get back to it in a bit.